estimate the mean from a frequency distribution. We have a frequency distribution right here. We have 3 classes, 0 to 4, 5 to 9, 10 to 14. The frequency tells us how many data values are in each class. So we have 15 data values in the range 0 to 4. We have 6 data values in the range 5 to 9. And we have 1 data value that's either a 10, 11, 12, 13, or 14. We don't know which one it is, but we know we have one of those values. Now we want the mean. Now we don't have the specific data values, so I cannot calculate the mean exactly. I have to estimate it. Now I have 15 values between 0 and 4. I'm going to pick the best value to represent those 15 values. And what I'm going to do is I'm going to use the midpoint of each class. The midpoint here is 2, the midpoint here is 7, and the midpoint here is 12. So I'm going to do my best guess by assuming that the 15 values are 15 2s. And then I have 6 7s, and then I have 1 12. All right, so you want to use the midpoints as the best guess here. The midpoints here are 2, 7, and 12. So I'm going to add up 15 2s, add up 6 7s, and I'm going to add 1 12. And then I'm going to divide by the total number of data values, which is 22. All right, so instead of doing 2 plus 2 plus 2 15 times, you can just do 2 times 15. That's the same thing as adding 15 2s. And then I want to add 6 7s. So that's going to be 7 times 6. And then I want to add to it 112. And then I want to divide by the total number of data values, which is 22. All right, so 2 times 15, that's 30. 7 times 6 is 42. That's going to be 12. This is going to be 84 up top. So the estimate for the mean, if you calculate 84 divided by 22, you get 3.8. That's going to be our best estimate for the mean of this frequency distribution. You can kind of see if the answer makes sense because the value that has the most frequency is 2, has a frequency of 15. So we should suspect that the mean is closer to these values up here because that's where the most of the data values are. And we get 3.8, so it makes sense. There you go.